topic is about problem solving with circles using circle theorems. I will go through recapping some prior knowledge about equations of circles and circle theorems before I go through examples. Feel free to pause whenever you want. Okay, now just as a reminder, the equation of a circle formula is x minus a squared plus y minus b squared is equal to r squared, where AB is equal to the circle center and r is equal to the radius of circle. Okay, so throughout these problems always have that equation of a circle in mind. Okay, now there's some circle theorems you'll need for these problem solving questions. So I will go through each of these. So the first one is the angle between a tangent and a radius in a circle is always equal to 90 degrees. So angle between a tangent and radius in a circle is equal to 90 degrees. So tangent and radius are always perpendicular. Okay, now the length of two tangents from a point to a circle are equal. So this length and this length are the same. So if we were to write it out, it's length of two tangents from a point to a circle are equal. Okay, next one. An angle subtended at the circumference by a diameter is always 90 degrees. So if you have the diameter here, then no matter what angle it makes at the circumference, it's always going to be 90 degrees. So if I make another angle here, even that one is 90 degrees. Okay, so I want to write it down. Angle subtended at the circumference by a diameter. So it's important that that length P2Q, the diameter, is equal to 90 degrees. And the last circle theorem, if the radius is perpendicular to a chord, then it bisects the chord. So this length and this length are the same, and vice versa. So if the radius is perpendicular to a chord, then it bisects the chord, and vice versa. Okay, so these are all the theories that you need in order to solve problems with circles. Another definition that you need is about tangents and normals to a circle. So if you have a circle, and this is the radius, and there's a tangent to a point on the circle, so that means it meets the circle at one point, so it touches a circle really. So this is called a tangent to a point on a circle. Okay, now a normal is perpendicular to a tangent. So that means if this is a tangent, and then let's change color, then the normal would be here. So it meets the tangent at 90 degrees. So this is a normal to a point on a circle. So the normal is perpendicular to the tangent. And because it's perpendicular, it means it will be the radius, which means it will go through the center as well. So that's quite important. So let's go through an example. Okay, so it says, find the equation of the normal and the tangent to the circle x squared plus y squared minus 8x minus 2y plus 12 equals 0 at the point 6, 2. Okay, so first I need to complete the square. So if I collect the like terms together, I get this. If I complete the square, I get x minus 4 squared, take away 16, plus y minus 1 squared, take away 1, plus 12 is equal to 0. If I simplify all the constants by collecting it, negative 16, take away 1, plus 12 gives me negative 5, so take away 5 equals 0, which means x minus 4 squared plus y minus 1 squared is equal to 5. Let's fix that up. Which implies the center is at 4, 1 and the radius is equal to root 5. So if I were to sketch this diagram out, so my circle center is 4, 1. My radius is root 5. Okay, for part A, I'm trying to find the normal. So the normal is if I have this point which is P, 6, 2, then the normal would be this A, and the part B, which is tangent, would be this part, which is B, and we know the normal and the tangent meet at 90 degrees. Okay, so let's do part A first. Now the gradient of the normal is equal to the gradient of the radius, so which is change in y over change in x, which is equal to 2 take away 1 over 6 take away 4, which I get half. Okay, now I know a point x1, y1 that it goes through. Now I have 2 points that it goes through. You can either use the center, because the normal goes to the center, or the point 6, 2. So you've got 2 options. So I'm going to use the gradient is equal to a half, and x1, y1 is equal to, let's say it goes through 6, 2. Then using y minus y1 is equal to m times x minus x1. I get y minus 2 is equal to half times x minus 6. Okay, so I can just leave in that form because it didn't ask for a specific form. Okay, for part B, gradient of tangent is equal to the negative reciprocal of the gradient of the normal, which is equal to negative 1 over a half, which is equal to negative 2. Now the tangent only goes through the point 6, 2. So I have gradient is equal to negative 2 and x1, y1 is equal to 6, 2. So using y minus y1 is equal to m times x minus x1, I get y minus 2 is equal to negative 2 times x take away 6. So that would be the equation of my tangent. Okay, let's go to the next example. So it says the point PQ lie on a circle with center C as shown in the diagram. The point P has coordinates -7, -1, and Q has coordinate 3, -5. M is the midpoint of the line segment PQ. So if it's a line midpoint, I know that this must be perpendicular there. The line L passes through the points M and C. Find an equation of L. In order to find the equation for L, first thing I need to do is work out the midpoint M. So M is equal to the midpoint of PQ. So all I need to do is add the x coordinates and half it, and add the y coordinates and half it. So what I end up getting is -4 divided by 2, which is -2, and -6 divided by 2, which is -3. So I've worked out a point that is on the line, which is M. Next thing I need to do is work out the gradient of L. Now I know that gradient L is perpendicular to PQ, so I can work out the gradient of PQ first. So gradient of PQ is equal to change in y over change in x, which is equal to -5 take away -1 over 3 take away -7. So I end up with -4 over 10, which is -2 over 5. So I now know the gradient between P and Q. Now the gradient of L, because it's perpendicular, L is perpendicular to P to Q, is the negative reciprocal of the gradient between P and Q, which is -1 over -2 over 5, which gives me +5 over 2. So now I have, using y minus y1 is equal to m times x minus x1, where my m, gradient of the line, is 5 over 2, and my x1 y1 is equal to the midpoint, which is -2, -3. I end up getting y take away -3 is equal to 5 over 2 times x take away -2, which gives me y plus 3 is equal to 5 over 2 times x plus 2. And if I expand that out, I get y plus 3 is equal to 5 over 2x plus 5, which means y is equal to 5 over 2x plus 2. So that is my equation of L. Okay, it says, given that y coordinate of C is -8, so this is x -8, show that the x coordinate of C is -4. Now because C lies on L, it must satisfy L. So for part B, I substitute y equals -8 into equation for L, which is I've worked out in A. Okay, so I end up getting -8 is equal to 5 over 2x plus 2, which means I get -10 is equal to 5 over 2x. If I times by 2, I get -20 is equal to 5x, which means x must be equal to -4, which I was trying to prove anyway. And for part C, find the equation of the circle C. So we know the center, because we worked out what C is now, is -4 minus 8, which means our equation of a circle is x plus 4 squared plus x plus y plus 8 squared is equal to r squared. Now in order to find r, I need to find the radius, so I can work out the radius by working out the distance between C and Q. So radius is equal to distance between C and Q, which if I do correctly is the change in x squared, so negative 4 take away 3 squared, plus change in y squared, negative 8 take away minus 5 squared, which ends up giving me 7 squared, which is 49, plus 3 squared, which is 9, which is equal to root 58. Now that I know this, my answer would be x plus 4 squared plus y plus 8 squared is equal to radius squared, which is equal to 58. So that would be my equation for the circle. The next example, the 3 points P minus 2, 7, Q 2, 3, and R 4, 5 lie in a circle. Show that PQ is perpendicular to QR. Find the equation of a circle which passes through the point P, Q, and R. So if I draw it out, so we've got a circle, we've got P somewhere here, Q somewhere here, R somewhere here, where P is minus 2, 7, Q is 2, 3, and R is 4, 5. Show that PQ, so P to Q, and Q to R are perpendicular first. Okay, so the gradient of P to Q is equal to the change in Y over change in X, which is 3 take away 7 over 2 take away minus 2, which gives you negative 4 over 4, which is equal to negative 1. In a similar way, if I do the gradient between Q and R, change in Y over change in X, then I get 3 take away 5 over 2 take away 4, which gives me negative 2 over negative 2, which is equal to 1. Now, since negative 1 times 1 is equal to negative 1, therefore PQ is perpendicular to QR. Now, because we know they're perpendicular, then what we do know as part of the circle theorem, that means that P to R must be the diameter. So P to R must be the diameter. So the first thing I need to do is find the center of this circle, which means I need to find the midpoint, so M, so here. So if I want to work out M, it's the midpoint of PR, which means I need to add the x coordinates together. So minus 2 add 4, divide by 2, and add the y coordinates, which is 7 add 5, and then half it, which ends up giving me 2 over 2, which is 1, and 12 over 2, which is 6. So that means circle center is equal to 1, 6. Okay, now I need to find the radius. So I know this is now 1, 6. So in order to find the radius, I just need to find the distance between M and R here. So radius is equal to distance between M and R. So if I do this, it will be 4 change in X squared plus change in Y squared, which I get 3 squared, which is 9, plus square root of 9 plus, therefore the square there, 9 plus 1, which gives you square root of 10. So all that implies that the equation of my circle will be x minus 1 squared plus y minus 6 squared is equal to r squared, which is equal to 10. So that would be my final answer. The next question. The line y is equal to negative 3x plus k is a tangent to the circle x squared plus y squared is equal to 10. So this circle has center 0, 0 and radius root 10. Use circle theorems to find the possible values of k. So if I sketch this out, so my circle center is the origin and my radius here is root 10. Now it says minus 3x plus k is a tangent to the circle. Now y is equal to minus 3x plus k is a negative gradient. So let's just draw a sketch. Then that would mean that is y is equal to negative 3x plus k. Let that represent that tangent. And we'd have obviously another one which is parallel, which gives us another solution for k. So y is equal to negative 3x plus k. Now if we draw a normal, then we know it will go through the center, which means that would also be perpendicular to the tangent. So which means the equation of this normal will be y is equal to the negative reciprocal of negative 3, which is equal to a third x. And there'll be no constant because it goes to the origin. So if I want to find these 2 points, then all I need to do is solve y equals a third x simultaneously with the equation of the circle. So substitute y is equal to a third x into the equation of the circle, which is x squared plus y squared is equal to 10, which implies I get x squared plus a third x all squared is equal to 10, which means I get x squared plus a ninth x squared is equal to 10. If I multiply by 9 throughout, I get 9x squared plus x squared is equal to 90, which means 10x squared is equal to 90, which means x squared is equal to 9, which means x is equal to plus or minus 3. If x is equal to plus or minus 3, since x is equal to plus or minus 3, y is a third of x, which is a third of plus or minus 3, which is equal to plus or minus 1. That means this first point is 3, 1, because it's in the first quadrant, and that point must be negative 3, negative 1. So if I substitute first, substitute the point 3, 1 into y is equal to negative 3x plus k, then I get 1 is equal to negative 3 times 3 plus k, which implies 1 is equal to negative 9 plus k, which implies k is equal to 10. That's one solution for k. If I substitute the other point, substitute negative 3, negative 1 into y is equal to negative 3x plus k, then I end up getting negative 1 is equal to negative 3 times negative 3 plus k, which means negative 1 is equal to 9 plus k, which means k is equal to negative 10. And that's my other solution for k. Another example. Prove that the equation x squared plus y squared take away 8x plus 4ky plus 3k squared is equal to 0 represents a circle for all values of k. So let's collect the x's together and the y's together and the constant at the end. Let's complete the square. So half the coefficient of x, which is negative 4, take away 16 plus y plus half of 4k is 2k minus 2k all squared plus 3k squared is equal to 0. If I clean this up, I get x take away 4 squared plus y plus 2k squared minus 16. From the negative 2k all squared, I get negative 4k squared plus 3k squared gives me minus k squared, which is equal to 0. If I take the constants to the other side, I get x minus 4 squared plus y plus 2k all squared is equal to k squared plus 16. So the circle centre is 4 negative 2k, and the radius is equal to square root of k squared plus 16. Now I'm trying to show that this represents a circle for all values of k. Now if it represents a circle for all values of k, then r must be greater than 0, which implies r squared must be greater than 0. So we have to show somehow that r squared is always greater than 0. Now r squared is equal to k squared plus 16. Now what we do know is k squared, which is a square number, is always going to be greater than 0. So k squared plus 16 will always be greater than 16, which is greater than 0. Therefore, r squared is always greater than 0. Therefore, x squared plus y squared minus 8x plus 4ky plus 3k squared is a circle for all k.